Hi, I wanted to show you my first SPI component for Nusbio. It is the 10k digital potentiometer MCP4131. Here is Nusbio. The white wire is the clock. In green we have select, and in orange we have MOSI, master out, slave in. The MCP4131 is not a standard SPI chip because it combines MOSI and MISO, master in, slave out. And so far I can send data, but I cannot read data. Even with an Arduino I had some difficulty. In a next video I will use a more standard SPI chip which has the right 4 SPI pin. I will use the multimeter to display the current going out from the chip. In this first demo, the output of the MCP4131, which is here, goes to a 10 ohm resistor and then goes into my multimeter, and my multimeter goes to ground. I am in the sample Nusbio SPI digital potentiometer MCP413X, which is on GitHub. Let's see how I initialize my Nusbio instance. GPIO 0 will be used as the clock. GPIO 1 will be used as the select function. And GPIO 2 will be used as MOSI, master out, slave in. Here it's called SDI, slave data in. For now, I will not read info from the device. As mentioned, I have some issues with the chip which combine both data line. I am setting MISO, master in, slave out, to none. Let's look at the test function. As a parameter, I'm passing the base class. There are multiple digital potentiometer part of the family, and the base class allow me to reuse some code, and this function will work for different type of digital potentiometer of the same family. What I'm going to do here is loop from the minimum digital value, which is 0, up to the maximum digital value, which is 128, and set the resistance of the potentiometer. And then I'm going to call this function that displays some information on the screen. I'm going to start the app and press 0 to execute the first test. That will go over the 128 steps of resistance. What I'm going to do here is set a breakpoint when we reach 1 milliamp of current. What do we see here? We are at step 65. At step 0, the resistance is 10,000 ohm, and at step 65, the resistance is 4,930 ohm. The input voltage is 5 volts, that does not change, and at 5 volts and 4,930 ohm of resistance, the current should be 1.01 milliamp. And you can see on the multimeter that the real value is 1.08 milliamp. Now I'm going to let the function finish. In this last part, I'm going to add the red LED to the circuit. And I'm going to run the LED test. What that test does, it goes from 0 to 128 and from 128 to 0, which make the resistance goes from 10,000 ohm to 0 and then from 0 to 10,000 ohm, creating a fade in, fade out effect. I'm going to slow down the execution. We are going to wait 10 milliseconds after each change of step. I'm going to slow it down even more. As you can see, the fade in, fade out is not linear, and that's part of the LED feature.